Good morning, everyone. Thank you for joining us. We're going to give it a couple of minutes just to let a few stragglers join us for the start. Um, and then we'll actually start with some housekeeping items. All right, well, let's get started. Thank you all for joining us today for our April Power Session webinar. The topic today are the hard-to-abate industrial sectors. As we've gone through our webinar series, we've done deep dives into transport, we've done deep dives into residential and commercial building decarbonization, and this session will be turning to the industrial sector and scanning the landscape for what sort of decarbonization targets do we need to hit? What is the state of play in terms of decarbonization technologies and their associated costs? And what's the outlook for those costs over time? Thank you for joining us. I will move to the first slide. Um, so I'll be assisted by Sarah. She is going to be managing the Q&A, so please feel free to drop in any questions along the way. She'll be managing those at the end. Also, there will be a poll as to our next uh, um, topic for the webinar series. We've got some very interesting ones, I think, in there, so please do take a look and weigh in. It'll be good practice for the upcoming election in any case. And I look forward to seeing what this audience votes on in terms of what's most interesting. So for today's section, we're going to cover the current policy and regulatory targets and settings, where we're starting from in terms of industrial fuel consumption and CO2 emissions, and then do a deep dive on the key end uses and industrial electrification pathways, and what is the outlook for some of those options. And then we'll finish with some key takeaways and recommendations, as well as turning towards the next Power Session webinar topic. I'm Ezra Bateman, Managing Director, and let's get started. So the Paris Agreement has largely dictated what any signatories to the agreement are targeting in terms of emissions reductions over time. And one of the key aspects of the agreement is that every 5 years, each country needs to review the cost of meeting their targets. And if those costs are to fall, then increasing the targets or the stringency of the targets so that we're constantly on a pathway to a decarbonized future at a pace that is commensurate with the cost situation. Now, I would point out that this doesn't always necessarily have to go down, and certainly in a period of rising inflation, things could actually cost more. But here we've got the current targets for Australia as part of the periodic updates. So here we're showing where we are now in 2025, excuse me, um, and what the pathway is to achieving the Paris targets. You also have, sorry, this is the baseline projection, and you have that broken out by the different sectors below. Electricity is expected to be one of the key sectors that decarbonizes to here is showing to 2040. The other sectors don't see quite as much decline as part of the baseline scenario. So turning to the state targets, you can see here that some of the states, and in particular the ACT and Victoria, are committing to a slightly accelerated emissions reduction target, aiming for 2045. Each of the other states at this point is still aiming for 2050. If you look at the state emissions by sector, they largely reflect the relative size of the economies, with some states that have significant mining operations in particular, showing a higher than their economy would higher than just pure GDP would suggest. So now let's do a deep dive into the sectors themselves. Here we're showing the amount of usage by fuel input. And you can see here that heavy duty road transport, mining, chemical, and petrochemical production are more than double total energy usage of any of the other sectors that we've called out here. The next sort of set are iron and steel production, aluminum production, and aviation. However, when you convert that into CO2 emissions, you can see that the ratios change a little bit, particularly petrochemical and chemical production isn't as CO2 intensive as some of the others, which by and large maintain the rough ratios of emissions that we saw in energy usage. So there's a fair amount of CO2 just contained in these key industrial segments, but they have those segments that are relatively high compared to the others. So now let's talk about the different abatement challenges and pathways. Here, and this one of the purposes of this piece of research was to really demystify, what about these processes is hard to abate, and how exactly does it produce emissions. And so I won't go into the detail here, but this is a resource to dive into to help those that are maybe not experts in cement production gain a better understanding about what the production process does that is emissions intensive, to better understand the potential solutions. When you look across all the different potential solutions, there are a range that are sort of generic, right? We can be more energy efficient. We can, to some degree, electrify. There may be alternative processes. In some cases, you could use green hydrogen, potentially to either burn it or as a feedstock. Pardon me. There's biofuels for some of the different industrial sectors, and then there are uh, sort of the alternatives. One is carbon capture and usage, or sequestration, or CCS or CCUS. And then there's offsets you can buy. We don't put in LULUCF, which is development of forests and carbon sinks, but that should go on this list as well. And you see here, we've sort of mapped by sector which of these solutions is relevant. And in some cases, you see electrification can be applied in each of them. Energy efficiency, the same deal. Hydrogen offsets, green fuels. But CCUS is not readily applicable to the heavy duty road transport, just because capturing the emissions it makes it really not feasible, particularly if you're at sea or flying. Alternative processes also are not necessarily suitable for each of these sectors. So let's turn to the specific sectors themselves. Here we've got iron and steel production, as well as aluminum or aluminium production, costs, and a list of the most promising carbon abatement solutions. And you see for iron and steel, we're starting off with alternative reducing agents, moving on to electrification, and then going to the more generic CCUS, as well as an alternative process in terms of being innovative smelting reduction process. Now, um, both the alternative reducing agent and the smelting process, vary from $1,700 per ton of CO2 to 118. It's not going to take out all of the CO2 in the process, and so it's going to actually decarbonize the sector. We're going to need a combination of all of these items, probably starting with the least cost one, moving up to the next costly, etc. Now here, the CCUS looks relatively attractive at 165. and is potentially unlimited. And I think what you'll see as we go through this list, many of these hard to abate sectors are believing that CCUS is going to be a relatively competitive way of decarbonizing the sector. And so one of the key insights or conclusions that we've reached in this analysis is that it's really important that we get better visibility on the potential for CCUS. And probably see more demonstrations that it's actually going to be able to do what the latest and greatest research suggests it can. LULUCF is another one that is out there and is one of the key strategies that the Commonwealth government is currently banking on to achieve its targets. For aluminium, you've got the alternative prices at 195 compared to $8 for CCUS. And then there are other electrification options here. Now, I know a lot of the R&D that's being directed at hard to abate sectors is really aimed at verifying these numbers and hopefully bringing down these costs. But that requires research and development and funding of research and development. Turning to cement production, again, you've got an alternative fuel here and electrified process heating. There's the CCUS, as well as being more energy efficient. Now, energy efficiency can only account, again, for a small fraction of the overall emissions. The alternative fuels could potentially provide a significant amount in a part of the production process, but the rest, at least with these three key strategies, is suggesting CCUS as carrying a lot of weight here. Petrochemical, they've got a wider range of options, although noting that depending on what your end fuel stock, what your end fuel or chemical product is, it actually has an impact on the CCUS price. Now, this was one of the things that dawned on me when we were doing this analysis is a lot of times we just look at, okay, what is the price of capturing carbon and either storing it or utilizing. When you get to storage, probably that's a little bit more generalized or generic. Using it probably depends on the kind of carbon, but certainly the capturing part of the CCUS or CCS is really dependent on the particular industry sector. And the key driver of why CCUS can range from 375 for cement down to as cheap as $17 a ton of CO2. And I think more insight into this, it will be important as we seem to be betting so heavily on CCUS to achieve the decarbonization, as well as LULUCF. And that probably from a risk perspective, it's important that we continue to invest in these alternative processes, including electrification. So turning to heavy transport, shipping, and aviation, you see here that the alternative fuels using fuel cells, for example, or drop-in biofuels, or electric vehicles for heavy duty, is looking like battery electric in most cases is going to be the most cost-effective. Shipping, it's a little bit of a different story. The biofuels there look to be the most cost-effective alternative. However, you need to be able to produce enough of them to meet all your needs. Otherwise, you have to step into higher cost solutions like energy efficiency and synthetic fuels. Ultimately, electrification of electric ships is looking pretty high cost at the moment. And then we look at aviation. I know there's a lot of focus on drop-in e-fuels because they are drop-in, or even biofuels. But what our analysis research is showing, and this is by way of arena work, that electrification actually looks to be more cost-effective. But there's a difference between electrifying, a Piper Cub sort of fixed wing, 2 to 4 passenger plane, and a 787. So again, each one of these potential decarbonization pathways may not apply to 100% of the sector and its process, and that not the lower cost options will have to be supplemented by higher cost options, or in order to achieve the targets that we need to aim for. All right, now let's look at what we found in terms of the outlook for prices. I see LULUCF has made an appearance here, which is great. So here's some research that was conducted by a number of sources. You see some of this is a little bit old now, 2021, 2022, looking at just generic carbon capture and storage costs and how those are vary depending on if they're liquid direct or air capture or solid direct and air capture. So even within this pretty generic approach, which was really focused on this multi-user storage hub concept, we have quite a big range of between 50 to up to $225 per CO2 dollar per CO2. I think that might be dollar per CO2 ton of CO2. Thank you. Um, if you look at LULUCF, that's looking a little bit more attractive here, somewhere between $40 and $140. Both of these, in theory, could meet 100% of Australia's hard to abate sector. Some of them will be higher cost than some of the process changes or electrification options, particularly with respect to heating and high temp heating. But it certainly is the backstop, and in some cases, the primary focus in terms of national decarbonization strategies. Now, on the bottom left, we've got capital costs as an indicator for the power sector of different kinds of power stations and how much they cost with and without CCS. And you can see the CCS adder is highest on a biomass plant because there's a lot more um, carbon that's emitted in the burning. But we can talk about the benefits of embodied carbon. But you see here the gas combined cycle has a smaller overhead for CCS than, for example, black coal. Now, turning to biofuels, here's a generic example of green hydrogen, and it's showing now that there is a premium. But the view is that when you take into account the embodied carbon, that you could start to see it become a negatively costed item. Now, this it would be great to have it be negative cost for the entire hard to abate sector, but biofuels are going to be limited by the amount that's able to be produced at these prices. And I know that there is a good paper that was paid for by Arena out there that that tries to take stock of how much biofuel is available, and we covered it in previous webinars. Green hydrogen here is a premium relative to natural gas, and while it is falling, even by 2050, it still looks to be about $25 of ton of CO2. So I think we've covered all of the major sort of generic costs, and then what we need to do is this carbon price that is really difficult to obtain. By the way, there are not that many out there. Is showing the carbon emissions reduction, right? So according to economics and market theory, this price needs to be high enough to achieve these reductions over time, and we can just go with the federal reduction here. And what's suggesting with these prices that early on it might be the low hanging fruit. And when we start getting into this territory, we start getting into CCS, or sorry, maybe some LULUCF and CCS and more um, sector specific process improvements and electrification. And then we start getting into the more expensive stuff over here. So to me, this forecast of price increases suggests it can't all be CCUS or LULUCF, that there will be the need to go beyond that to achieve the targets. However, just based on the research we've done here, it might be that the CO2 price doesn't need to get this high, but it really depends on how much and how cost effective LULUCF and CCS and CCUS are, and how well we can get down some of the other more niche uh, strategies in terms of process improvement, feedstock, etc., to keep driving the carbon cost down over time. So the key takeaways and recommendations from our work to date are that these hard to abate sectors are 2/3 of baseline emissions in Australia. So this is on top of the decarbonizing your water heater and whatnot in residential dwellings. So it's really important that these emissions get abated and get abated at least cost. What we also found is that a large proportion are not suited to electrification for a range of reasons. And while specific solutions are being developed in each case, they can be high cost. So the CCS, CCUS general offset approaches are probably needed. The question is how accurate those cost estimates are, and how can we reduce them and ensure that we've got sufficient capacity to accommodate the amount of emissions that need to be reduced. So our recommendations from this work are that this high temp heat technologies to electrify, plasma-based solutions, etc., are a key solution, and more information and R&D is probably called for to try and keep costs down as low as they can be, particularly as we prove up the CCS, CCUS, and LULUCF solutions that are more general. R&D is going to be a key focus and the key to helping to manage the risk and keeping costs as low as they can be. Biofuels can look attractive in some of these sectors, but they are limited in their supply. And that green hydrogen, although it's high cost now and will remain high cost, is probably the only thing that could meet the gap of a biofuel cost in the future when you need it for a feedstock to get us to 100% net zero carbon by 2045 or 2050. So that was the webinar. Thank you very much for joining us. Now we're going to go into the Q&A session, and please don't forget to vote on your favorite topic for the future. These first two, I think, are very topical. First is the nuclear technology and cost effectiveness. We're looking at investigating that and bringing some more data and information to the discussion, as well as applying AI to an expert chatbot and seeing how well it does. And maybe we can even ask questions of it during the webinar and see how you go. I think just based on my own background, we'll be looking more at tariff design than asset management, but it's a start. Virtual power plant programs, as well as potentially heavy and medium duty transportation electrification, climate and weather impacts, and then workforce analysis and planning. So thank you very much for making some time. I hope you enjoyed that and looking forward to your questions. All right, first question, is the change in the cost of capturing carbon purely driven by concentration of CO2 in the flue gases? The higher the concentration of CO2, the lower the cost. I am not enough of a CCS expert, but all of this analysis and research suggests that becoming more of an expert is going to be useful and important to the industry at large because we're betting so much on it. So I apologize, but I don't have an answer for you for that question. The graph showed cost to abate by solution, but not all of the options can achieve the same level of emissions reduction. What portion of emissions can be captured by CCS for each sector? Look, I think this is really a critical question, and we started to try and do that, but the amount of research that's required, I mean, CCS and CCUS in theory could do 100%, right? You just have to bury the emissions or make enough roads or use it for cement pillars. The other ones are a lot harder because you have to understand how much of the emissions comes from that particular element of the process, how much comes from that particular feedstock. So it's a non-trivial analysis that we'd love to see more detail and more funding be devoted to before we can answer that question. So I think in summary, right now, it's not clear to us that how much CCS can abate, what the supply cost curve of CCS is, and that CCS and LULUCF probably warrant their own deep dive, just so we're really sure that we're not just relying on magical thinking. Something seems wrong here for iron and steel. For electrification, you still need to make the direct reduction, the DRI, before you can use an electric arc furnace. So you need to reduce, well, it sounds like I'm dealing with a specialist here, so well done. We didn't make any of this up, so we can take this on notice and come back to you with the answer just based on the research that we've done so far. Thank you. Do you think the safeguard mechanism is sufficient to drive least cost decarbonization? Now, the safeguard mechanism that I understand is the scheme put in place largely with respect to generation, electricity generation. Um, and I'm not a detailed expert on exactly what the terms are now, so I don't know that I can quite answer that. To me, to drive least cost carbon, I'm a more of a fan of um, of one of the schemes that Australia's tried, that was shelved, whereby you put a price on the value or the cost of carbon, and then depending on how intensive your usage of it is, uh, drives whether or not you're a net payer or a net buyer of certificates. So sorry, that wasn't a direct response to your question, but I think it was quite a difficult question to answer directly with my knowledge. Do you include biomethane? Yes. Okay. So biomethane, generally we like to talk about renewable natural gas or RNG because it's a drop-in. Biomethane um, is not necessarily a drop-in, and so there are some additional costs and risks associated with blending it into whatever it is you're doing, as far as I understand it. For many abatement options, prices are likely to fall initially with scale as technology improves. 100% agree. But then rise as capacity constraints kick in. Understanding this will help decarbonization decisions. Is anyone modeling this? Not as far as we have been able to see. I mean, this whole industry learning curve and where we are in that, and we've done work for research agencies to try and identify what learning rates are for different technologies and where you are in this sort of um, R&D, commercialization, your commercial readiness. And so all of those factors are important, and understanding exactly how much you need to invest to get technologies to a certain point, that's all important. The other issue is just how big Australia is compared to the world. And generally a dominant strategy here is to make sure you're not investing in general improvements and you're harnessing others' investments there, but spending more on localization and specific Australian um, aspects to the technology that other folks are not going and to invest in. I'll take one or two more questions, and I think that I'll thank everybody, so everybody can get on their way to the next thing they need to do. So look, hydrogen was going to solve all problems about 5 years ago. It can do anything. The problem is how much it costs to do those anythings and what the alternative solutions are. And so we've systematically seen evidence that hydrogen's probably not going to win in transport, at least ground transport. Hydrogen is probably not going to win as a power sector fuel, in my opinion. Um, but in terms as a feedstock to a chemical production, it's really it and other sorts of biofuels that can get us there, or really, some chemical engineering. So I think there's always going to be a home for hydrogen as a feedstock, and whether you do biofuels or you do hydrogen is going to be a function of how much it costs relatively. Um, Other than that, we can look at, how do we transport large amounts of energy over long distances the most cost effectively? Is that ammonia? Is it hydrogen? I've seen arguments both ways. So I don't know that I would say it's a large need for hydrogen as a feedstock, but I think I would be surprised if hydrogen doesn't find a niche in the decarbonization fuel future, and probably in the feedstock area. That would, if I had to place a bet. What would you do in the near term to minimize the cost of hard to abate transition? Great question. I think a lot of it is in the R&D, um, continuing to do work around current cost curves, current potential to bring those cost curves down. We were asked by a client once to look at what are the key cost reduction factors. And I know the DOE does it. I know Arena's paid for this sort of research, but let's be scientific and systematic about this and put dollars where they seem to be the best bets. It may not turn out to be true, but the main thing is to have best available information and make strategic decisions, make that decision making framework transparent, and evolve it over time. Look, it's now the hour, so I want to thank everybody. I know you got other places to go. Appreciate you spending some time with us. Appreciate your questions, and also your votes. And I look forward to hopefully seeing you at our next webinar. And don't forget to sign up if you haven't already, so that you get automatically notified. Thank you very much, and have a great rest of your day.